I can.
Camera is off.
How will I turn it on?
The red button on the center.
Red. Okay, so there can they see my here?
Can't read it. Use your sorry. You can share your screen. Then use your real-time board to
Again, dear.
you do it on the screen, on your screen using real-time board app.
Oh, okay.
Can you
How
give
do
me
I
the
do
link?
that? How do I reverse it through the screen?
Go to your scroll mouse over your screen. Sa
Huh?
live.
Where?
Center sa screen mo ba? Pag mouse over, then you'll see these apps on the left.
Uh-huh.
The green one is your screen share. I-click na siya.
Kani?
Yep. And
Select
then you can
application
choose
window.
your entire screen or whatever window you would like to share only. So you share your entire screen na lang. Yeah. And then open to another window.
Open to another.
Open the other window you want to open, like your real-time board or what.
Karuna. So I can hang this.
Oh, and you can minimize that.
I can minimize
So,
this one.
so then viewers na lagi ka.
Asa to? Asa naman to?
Kana.
This one, what do you see now?
No, I can naka-hangouts mo ka na ako. Kana. What they'll see is what you see on your screen.
What you see on your screen? Let me.
Go back to your console. Go back to your hangouts on air.
Hangouts on air. Where can I see?
Dili naman.
Asa mo rin ako makita, dear?
It's in one of your windows probably.
It's not here.
It's there. Kaya hangouts video call.
Where, dear? Where?
Kana ko ng YouTube. Kana ko ng YouTube.
Kani YouTube, kani?
Wala. Dili
Kani?
mao.
Can
Ako
I
na.
see myself?
Open ko na lang. No?
You are.
Kana ko ng YouTube. Kana ko ng YouTube.
Yeah, that's kani YouTube, kani?
Wala. Dili mao.
There are 12 watching now. There are 12 watching now. Sorry, we're setting this up. Sorry, we're setting this up. There are 12 watching now. There are 12 watching now. Sorry, we're setting this up. Sorry, we're setting this up. There are 12 watching now. There are 12 watching now. Sorry, we're setting this up. Sorry, we're setting this up. Dear. I will now. Dear. Dear, it's so noisy. Wait. I don't know how to do the. I think I stopped screen sharing. So if I will stop this, I will just go back to what I did, right? I will have to call you. Let me figure this out. Thank you, dear. Eat your lunch. I will not eat my lunch until I become successful in this. Sige, dear. Okay, dear. Bye-bye. Thank you, dear. Wait, hi guys. For now, I think I have to cancel this live stream for now. I will have to encode the problems first in the real time board so that it will be fast later on when I discuss. So this is just a trial. Please let your classmates know what's going on, and if, for those who need some explanation about the problem, much better that they do live stream in a while. So let me just cancel this for now, okay? Okay? Okay, wait, I need to. Okay. I think this is okay. Wait. Okay. Wait. Okay. Wait. Can you hear me now? Can you hear me now? Can I have some comments? Okay. I will now discuss. I will start discussing problem one. Okay. So this is now problem one. You see, it's about aluminum hydroxide's reaction with hydrochloric acid. Now, in this problem, there are 5 things that you need to answer. You have to understand that there are 4 substances that you are dealing with. So let me highlight this. You have aluminum hydroxide that reacts with hydrochloric acid, forming your aluminum chloride and your water. Now, this is stoichiometry. That means you have to always start with a balanced chemical equation. That's why part A is the first step. You need to be able to know first how to balance it correctly. Now, based on the papers that I've checked, there were others who did not balance this correctly, or sometimes the coefficients were not expressed in lowest terms. So that means you need to be very careful in balancing, in which balancing tomorrow is still part of the test. So you need to recall how to balance your equation properly. So let me write that again. So we have your aluminum. Let me thicken this a bit. Okay. Let me erase this. 10. Okay. So you have aluminum hydroxide AlOH3. Now if you see a parenthesis and with a subscript outside it, that means that the three here will be distributed to O and H, not including the Al. So there's 3 O's and 3 H for aluminum hydroxide alone. Then you have plus HCl. So you have another H here, so a total of 4 hydrogen, and then another chlorine, another element chlorine. And then you are forming the products, aluminum chloride, so AlCl3. So that's obvious that you have 1 chlorine, and 1 aluminum and 3 chlorine. And then plus H2O, so that's 2 hydrogen and 1 oxygen. So remember that you may start with something that is obvious because you need to be quick. Obviously here, chlorine. Chlorine is 1 and 3 here. So you might experiment with chlorine. To make the chlorine 3 here, you can put a 3 coefficient there, which affects hydrogen. So if it affects hydrogen, that means you have 3 hydrogen here plus 3. That makes it a 6. So that means I can make the 2 hydrogen on the right side 6 by putting a 3 there. If I put a 3, I will see that there are 3 oxygen, which balances out the 3 oxygen on the other side. And on the other hand, for aluminum, there's 1 aluminum and 1 aluminum. So that means the equation is already balanced. So you may start with the ones that are obvious, especially if your chemical equation is not a combustion reaction. So we started with chlorine, and then we played around. Next to that is hydrogen, and then oxygen became 3 after. So that makes your equation balance already. So you have to start with that because again, in the final exam, balancing, there's a separate items for balancing alone. And so you need to recall this. You need to ensure that after you leave balancing, check first whether your coefficients are all expressed in lowest terms. In this case, some answers where they put a 2 and a 6, a 2 and a 6 here. That means you can still simplify it as 1, 3, 1, 3. So this is the correct balanced chemical equation of the reaction between aluminum hydroxide and hydrochloric acid. Now let's go to letter B. Letter B, because you have different items per section, I'm just using one item here, but more or less the problems are the same. So they have the same approach. So don't wonder if the values do not coincide with what you had in the test. So letter B, let's read it properly. Calculate the number of grams of hydrochloric acid. So that means you're looking for this that can react with 0.250 grams of aluminum hydroxide. So that means you're given, you have to know how this is naming and formula writing already. Aluminum hydroxide is AlOH3, that's your given. And you're asked for hydrochloric acid. So that means you focus on these two substances and their coefficients. And because you're given the mass, that's mass of AlOH3, and you're asked for the mass of hydrochloric acid, that means it's a mass to mass calculation. Now recall your roadmap. When it's mass to mass, you have to always begin with your given mass. So you have 0.250 grams of aluminum hydroxide, AlOH3. Now, if it's a mass to mass, the first conversion factor is the molar mass of your given, meaning molar mass of aluminum hydroxide. Now, there are still others who got this wrong. Aluminum hydroxide, how do you get the mass? That means 1 Al, then 3 times the mass of oxygen, then plus 3 times the mass of hydrogen. Now, if you happen to forget that, please recall how to get the molar mass correctly because you won't be given the molar mass tomorrow. So, calculating that with my periodic table, I got 78 grams. So where will we, let me erase that, it's not clear. Where will we put the 78 grams? 78 should be below so that you can cancel out the grams of aluminum hydroxide. So that is aluminum hydroxide. You have to label it so that you won't get confused with the substances. So this is still the molar mass of your aluminum hydroxide. There are still others who did not put 1 mole in the molar mass value. Remember, if it's molar mass, it's always 1 mole paired with the gram value that you got from the periodic table. So now that we're done with the molar mass, then we will proceed to mole ratio. Do not proceed to mole ratio from the mass. It has to pass by molar mass first. So you need to now multiply it by the mole ratio between our given aluminum hydroxide and our required hydrochloric acid. So which it's 3:1. The 3 has to be on top because that's what we're looking for. That's 3 moles of HCl for every 1 mole of aluminum hydroxide. What's the goal of this? So that we can cancel out mole hydroxide. Okay, so if you see, the cancellation will now be like this. Grams aluminum hydroxide will cancel out. Moles aluminum hydroxide will cancel out. Then we still lack our molar mass of hydrochloric acid because we need to get grams of hydrochloric acid. So that means we need to multiply this further by the molar mass of hydrochloric acid, which is 1 hydrogen only and 1 chlorine. So that means you will get mass of 36.46 grams of hydrochloric acid. Again, for every 1 mole of HCl. So through that, you can already cancel out mole HCl. Okay, so that is you're left with grams HCl, which is what is required in the problem. Okay, so again, if this is the kind of problem, pass by molar mass first of the given because the given is a mass. Then right after that, mole ratio, and then molar mass of the required. Putting this in the calculator, you will get an answer of around 0.35 gram of hydrochloric acid. So that's it for letter B. Tell me if you have some questions. Let me proceed first to YouTube for some questions or clarification so I can answer them before I proceed to the next item. Okay, next, no questions? Letter C. Letter C, there are also others who were tricked by this. Letter C is asking for two things. Letter C is asking for the number of grams, so this is mass again, of aluminum chloride and the number of grams of water. So two things. Aluminum chloride, which is AlCl3, not AlOH3, okay? Aluminum chloride and the grams of water formed when you're given 0.250 again of aluminum hydroxide. So you're given 0.250 again of aluminum hydroxide, and you have to get two things, the mass of aluminum chloride and the mass of water. So this is still a mass to mass conversion, but there will be two. So let me erase first. Let me erase all of these things here so I can proceed to part C. Okay, so part C is asking you to solve for your aluminum chloride and water. So we do it one at a time. So let's start with aluminum chloride. So again, in every stoichiometry calculation, you have to begin with your given mass. So that's 0.250 gram of aluminum hydroxide, AlOH3. Since it's aluminum hydroxide's mass, so you have to proceed by multiplying it again or dividing it with 78 grams, which is the molar mass of aluminum hydroxide, which is always 1 mole. Then right after that, you have to proceed to mole ratio. What mole ratio? Because the first thing you're looking for is aluminum chloride, so that means you need to look at the mole ratio, which is just 1:1. So 1 mole of AlOH3 for every 1 mole of AlCl3, because that's the first one we're looking for. Because you're asked for the mass, that means you proceed to the molar mass of aluminum chloride. How do you get the molar mass again? Let me repeat this for those who did not get the molar mass correctly. There's only 1 aluminum and 3 chlorine. So that's mass of aluminum plus 3 times the mass of chlorine, in which you will get 133.33 grams of aluminum chloride for every 1 mole of aluminum chloride. The mole has to be below because we need to cancel that out. And of course, the mole AlOH3 and the grams AlOH3. So you are just canceling units that you don't need, and make sure that when you cancel, it should make sense why you're canceling it out. You just don't do canceling for the sake of canceling. You have to understand why you're canceling it. And if you want to get water before we input it to the calculator, we still begin with 0.250 grams of aluminum hydroxide, because that's what you're given. And still, you have to multiply it with the molar mass of your aluminum hydroxide, which is 78 grams of AlOH3. But the next one, because we're looking for water, that means you look at the mole ratio of water and aluminum hydroxide, which is 1 mole AlOH3 should be below so that you can cancel out AlOH3, and then 3 moles of water. And then because it's water and you're asked for the grams, that means you need to multiply it with the molar mass of water, which is 18.02 grams of water. So that's it. If you look at the solution, we also cancel the grams AlOH3, mole AlOH3, and mole of water, and then you get grams water. Same thing with the one above. You get grams of aluminum chloride. So in that case, the solutions are more or less the same, except that you need to be clear on where do you start and where do you end. So basically, you start with what you're given and you end with what you are required. Again, don't be tricked by that, and read the problem carefully so that you know what you're looking for. Inputting the two in the calculator, you will get for aluminum chloride, you will get the answer to be around 0.43 grams of AlCl3. And for water, H2O, you get around 0.17 grams. So these are the answers. Kindly check with your calculator if you got the answers correctly. I hope this is making sense to you now. Please let me know if you have some questions through your comments. I am now using my phone for the live chat, so I would have a separate screen for that. Okay, Darren, which topic is this, madam? The topic is about the test 2.5 items. The test 2.5 items that some need some discussion and some refresh discussion about the items. Okay, can I now proceed to part D? Okay, part D is about show that your calculations in parts B and C are consistent with the law of conservation of mass. Now, let's refresh our part B. Our part B's answer was 0.35 grams of HCl. This was part B. Then part C, you now have 0.43 grams of AlCl3 and then 0.17 grams of H2O. It says in part D that you need to be able to justify that your calculations are consistent with the law of conservation of mass. Now, for those who did not recall what law of conservation of mass means, it means that the mass before and after the reaction should remain the same because no atoms are destroyed nor created in the process of a chemical reaction. That means you just destroy old bonds and then the atoms get reshuffled. So it means that the total mass to the left of the arrow should be equal to the total mass to the right of the arrow, meaning the product side. So how do we know the masses? These are the masses that you know of. You know that your HCl, let me zoom that. Your HCl is, let me use a different color. Your HCl from your part B is 0.35. And from the given, you know that this is 0.250. And from your calculations on part C, there are two answers. So you got 0.43 for aluminum chloride. And then for water, you got 0.17, right? So if you have these masses, that means you can just add 0.250 plus 0.35 and you get what? 0.6 gram. And you add 0.43 plus 0.17, you also got 0.6 gram. They're equal. So that means the law of conservation of mass is followed. If it happens that you did not get this mass, that means your calculations in the previous items are incorrect. So you see there's a connection to your previous calculations why part D is asked. Correct? So there's a connection. That means it matters. So part B, we use that to get HCl. Then part C, you notice that it's still the same given 0.250. And then you got two values, 0.43 and 0.17, because in part B, it's being used so that you can confirm whether the mass doesn't really change after the reaction. Now, do you understand? Do you understand? I need your comments before I proceed to the next item. Any questions? Any questions? Can you still hear me? Can you still hear me? Can you still hear me? Okay. Okay, loud and clear. Thank you, Zoran. Because in my phone, there's something went wrong now. Something went wrong. I hope I can still be heard. Am I still online? Now, so you know the connection. So you will expect that in the items tomorrow, you'd expect questions like that. So always anticipate that each question matter because it's going to be used to the questions that will follow. Okay? Now let's go to part E. Let me erase the screen. So in part E, let me just erase everything now. Part E is you're asked for limiting. This is LRER item. LRER because if you notice, you are given two variables. What are these? I mean, two values, two amounts. But there's a trick here because I place here 10 moles of aluminum hydroxide and then 100 grams of hydrochloric acid. So that's a mole and a mass given. But it's both the reactants because aluminum hydroxide is a reactant and hydrochloric acid is also a reactant. So if you're given two amounts of the two reactants, that means it's an LRER problem. But basically, there will be two approaches because one is already a mole, that means you proceed to mole ratio right away. And the other one, because it's a mass given, that means you need to pass by molar mass and then mole ratio. But always the same concept, you need to focus only on one product. Let me focus on one product, aluminum chloride, because there are no questions that follow it. So you may just stop until the mole. You don't have to proceed to the grams. Unless if there's a letter F here, and the letter F will ask you for the percent yield. And if the actual yield is given in grams, that means you have to proceed to mass. But in this case, if it's just until identifying LR and ER, that means you just have to stop until the mole. That will make it quick and easy. So as what you've understood from LR, ER, you need to have two calculations. So let me start with 10. So you have 10 moles of AlOH3. Because it's a mole, basta mole na ganyan given, that means you can proceed right away to mole ratio. Because remember, the heart of stoichiometry is mole to mole, which is mole ratio. Because it's mole already, so you can proceed to mole ratio right away, in which the mole ratio of aluminum hydroxide and AlCl3 is just 1:1. So that's 1:1. So 1 mole AlCl3 for every 1 mole of aluminum hydroxide. That's it. So you get mole AlCl3. For the other given, which is the 100.0 grams of HCl, that means because this is a mass, you can't proceed to mole if you don't pass by molar mass. You know that. If it's a gram, it's always the molar mass automatically. Molar mass of HCl is 36.46 grams HCl. Again, for every 1 mole of HCl. And next, because I'm focusing on aluminum chloride, so I need to know the mole ratio of HCl and aluminum chloride, which is 1:3. So that's 3 moles HCl for every 1 mole of AlCl3. So that's equals. I end up with the same substance. So mole AlOH3 is cancelled out. Grams HCl is cancelled out, and mole HCl is cancelled out. Then I get mole AlCl3. Because it's an LRER, so I should end up with the same product. And then I will get the answers to this are, this is 10.0 mole of aluminum chloride, and this is 0.91 mole of AlCl3. Okay, and then you choose now the lower amount of product that is produced with the two reactants. The lower amount is of course 0.91. Now there are items in the There were items in the test in which you made a conclusion that 10 moles is the ER and 0.91 moles is the LR, which is not correct because you need to answer either aluminum hydroxide or HCl for the LR-ER. So since 0.91 is the lower amount, you go back. What produces that? It's HCl because we're talking about reactant, not the product. So HCl is the LR. HCl is the LR, and automatically your aluminum hydroxide is your ER. Okay, be careful with that when you make some conclusions. Darren, 3 ang HCl, Madam, kaya that's the number before it in the balanced chemical equation. Yes, you're correct. Yes. The three moles HCl came from the balanced chemical equation that I showed earlier. Always remember, the mole ratio will always come from your balanced chemical equation, the coefficients. And if you're talking about the mass, like for example, mass of 36.46 grams HCl, where did it come from? Did we include the 3? No, we did not. Just consider the quantity of each element using its subscript. If there's no subscript, it's understood to be 1. We did not include the coefficient 3 in calculating for the molar mass. Any more questions, Darren? Any more questions? Please don't hesitate to ask questions if ever you have some clarifications, okay? For those who commit a mistake in their final conclusion, in their final answer, because the question states that identify the LR and the ER of this reaction, that means you need to have a conclusion. You just don't jump right away that after calculating that's LR right away and that's ER. No, you need to go back to what reactant is that. You don't make a conclusion from the final answer. What is Simon's question? What is Simon's question? May I know? Before I proceed to item number 2. Item number 2 is about sodium azide. Can you tell me your questions? Okay. Any questions for item number 1? So that's basically item number 1. Reactivity. Okay, solubility rules and reactivity series. No? No need to memorize activity, series, and solubility rules. Why no need? It doesn't mean it won't come out, but it means that you really don't need to have the individual rules, the technical rules, and the order of the elements in the reactivity series, because you just need to read the items there, because in the items there are hints that will guide you through identifying whether that substance is insoluble or not. That's for the solubility rules. Like, for example, you're doing the net ionic equations, and then you have to know which is the solid in the product side. That means there will be mentions of precipitate, or there will be adjectives like insoluble. That will give you an idea that, yeah, this is my solid, and then the other one is aqueous. Aqueous means it's soluble in water. Do you get it? So it doesn't mean that it will not come out. Concepts will come out, but You need not memorize the technical aspect of it. Same thing with reactivity series. The application of reactivity series was for the single displacement reaction. So if it's a single displacement reaction, if you are given an equation and it says no reaction, that will give you an idea that, hey, this metal cannot replace this other metal because this metal is under this metal. You see the concept? So you still have to understand the concept, to understand the concept behind it, the concept behind everything that governs it. So what's the concept of single displacement reaction? For a single displacement reaction to proceed, it has to be able to be on top or more reactive than the other, but no need to memorize the order. Okay, is that clear? Is that clear? Does it clarify you? Does it clarify you? Does it? Okay. So I think it's now okay to proceed to the second problem. Okay, so this is, you may take a screenshot of problem number 1 if you did not really get it before I erase it. Or I'll just leave it there and then I will encode fast the problem number 2. Okay, and in the same screen, and then I'll just put the solutions below it. Okay, I hope this live streaming is helping you, and I hope you're done with your lunch. I'm not done with my lunch yet because I'm so occupied with this, but I'm not hungry. I'm enjoying what I'm doing. I hope you too. So this is problem number 2. Automobile airbags inflate when sodium azide, which is I place there. What's the chemical formula of sodium azide? That's NaN3. Rapidly decomposes to its component elements. Component elements. So the equation is NaN3, and then it produces the decomposition reaction, produces your sodium solid and your nitrogen gas. Question letter A. Write the balanced chemical equation of the reaction. Part B is how many moles of nitrogen gas. By the way, if you haven't eaten your lunch yet, can you please get something that you can eat while you are watching and solving this problem again? I hope you can grab a bite or just grab any food, finger food that you can eat while you're studying. That will improve your alertness. I hope so. And then letter C, that's how many grams of sodium azide are required to form 10.0 grams of nitrogen gas. And then you have part D. Part D is how many grams of sodium azide are required to produce 20.0. This is where majority of you got wrong in the conversion of cubic meter to liters. Just remember, I'll just put it here. 1 cubic meter, that's equal to 1,000 liters. That's a conversion you need to remember. So that's 20 cubic meter means that's 20,000 liters of, this is nitrogen gas. If the gas has a density of 1.25 grams per liter. And then last question, letter E. Expand it a bit. So using the mass of sodium azide in part C, solve for the amount of solid sodium that will be produced. Okay, so let me, yeah, you just eat. Anong one human uses sa school? No need. Okay, before I'm gonna solve this in your on the screen, can you at least try to approach this problem? I hope you're trying now based on what you've studied since Saturday, I think. I hope you can now relate, or you already have, I mean, the approach to this, I hope it's pretty clear to you already. Because if it's not, that means you still have a lot of work to do. And basically, if you understand item number 1, much of the methods here is more or less the same, except that the new thing here is you need to do some conversion. Letters A, B, and C, no need for conversion, not yet. In letter A, it says that you need to just balance the chemical equation, which is, I think it's pretty easy for you. Now, for those who did not recall the balanced chemical equation, again, that's sodium azide. Again, know the name. Know the name and the corresponding chemical formula, because if it gets mixed up, you won't be using the right values for these substances, or you will be using the incorrect mole ratio. So that's sodium azide decomposing into the solid sodium and nitrogen gas. This can be confusing because there's a lot of N. But as what I have always told you in class, you should not confuse it as long as it's clear to you what elements you're talking about. Na is different with N. Na is sodium, N is nitrogen. And so every time you're dealing with 3 and a 2, obviously you make it 6, right? So obviously you're gonna put a 3 here to make N2 6, and you put a 2 here to make N6 also, which affects Na to make it a 2, then you put a 2 here. Basically, that's it. So your 2, 2, and 3 are all simplified. So that's okay. Okay? So I hope that you will not commit a mistake anymore when you balance the chemical equation. Letter B. How many moles of nitrogen gas are produced by the decomposition of 1.50 moles of sodium azide? This is easy because every time you're dealing with 1.50 moles, moles na gani ang unit, that means you can go right away to mole ratio. You don't have to pass by molar mass because you're already given 1.50 moles of sodium azide, NaN3. And when you have this, you can just easily get what you're looking for. It's moles of nitrogen gas, in which you just get the mole ratio of nitrogen gas and sodium azide, which is 3 and 2. 2 for sodium azide, so 2 moles NaN3, and then 3 moles of N2. That's it. And you get what you're looking for because you can cancel out mole NaNH3. So that's 1.50 times 3 divided by 2. There are others whose solutions are correct, but in the end, in the answer part, it becomes incorrect. So the answer here is 2.25 moles of nitrogen gas. Make sure that you input it in the calculator. It's clear to you what's on top and what's below. So basically that's it, because it's a mole given to a mole required. So just mole ratio. That's all. Letter C. This is how many grams of sodium iodide are formed when you have 10 grams of nitrogen gas. You're given mass of nitrogen gas and you're to get grams of sodium azide. So this is mass to mass, same as what we did in the previous item. So we begin always with our 10.0 grams of N2. And then because this is N2, 2 is a subscript, include that in the molar mass calculation. So 14.01 times 2, that is 28.02 grams of N2 for every 1 mole of N2. Okay? So after molar mass, that's the time you can start with mole ratio between sodium azide and N2, which is 2 is to 3. So that's 3 moles N2, and that's 2 moles of NaN3. And because you're asked for the mass of sodium azide, you need to proceed to the molar mass of sodium azide, which is for every 1 mole of NaN3. O kani, daghan kay nasayo pa ni sa molar mass. It should be 65.02 grams of NaN3. Okay, that is the solution. So we cancel out grams N2, mole N2, mole NaNH3, and we get grams NaNH3, which is the one being asked in the problem. So we now have inputting everything in the calculator, and I hope you got this right because you're going to use this in part E. So that is 15.47 grams of NaN3. So 15.47 grams, that is your answer to part C. How are you doing so far? Did you get this? Did you get this? I hope you got this right. Yeah, 15.47, Darren, that's okay. Yes, nice, correct. Darren, make sure that you know how the molar masses were calculated. Make sure it's accurate, okay? Make sure it's really accurate, because if it's not accurate, you won't get the correct answer. And know when the mole ratio is used. And if it's molar mass, it's always 1 mole, okay? The partner of your gram is always 1 mole. Do not mix up mole ratio and molar mass. Any questions so far? I'm going to erase my solutions to parts B and C. And then I am going to solve for part D, which is a density related problem. So let me erase. I hope you took note of that already for those who did not get it. And please recall your paper, your common mistakes, so that you will not commit the same mistake again. Okay, let's go to part D. Okay, I hope you understand that in part D, you are given these things. You are given 20 cubic meter of nitrogen gas. This is nitrogen gas, which has a density of this, 1.25 grams per liter. But you are asked for sodium azide. That means you begin with nitrogen gas density and your volume, which is 20 m cube. Density and volume will give you mass, which is mass of nitrogen gas. Nitrogen gas nga massa, not the sodium azide yet. And then the moment you get the mass of your nitrogen gas, then that's the time you can get the mass of your sodium azide. So it's a mass-to-mass calculation. That's where stoichiometry is. This is not purely density-related problem because it's nitrogen gas, but you asked for sodium azide. So that means there's stoichiometry in this calculation. So let's begin. Every time it's a density of a given substance, you begin with the density of that substance. So I told you that the conversion of m cubed to liter is 1 m cubed is 1000 liters. So that means to solve for mass of nitrogen N2, that is density times volume. So density is 1.25 grams per liter times 20,000 liters. May I know what's your answer? Of course, the answer will be 25,000 grams, and the unit is just substance N2. Let me clear that. Let me clear this. It's N2, not sodium azide, please. That's still the first step. Getting the mass of your nitrogen gas. Okay, it's still N2. So how do we make use of the mass? To get the mass of sodium azide. Simple. That's your mass to mass stoichiometry, in which you begin with your 25,000. So I begin with 25,000 grams of N2. So times, because it's mass to mass, of course, the first thing is you need to have the molar mass of N2, which is 28.02 grams of N2 for every 1 mole of N2. Times, after molar mass, you know its mole ratio of your required, which is NaN3, and your given, which is N2. So that is 2:3. So that's 2 moles of NaN3 for every 3 moles of N2. And then because you asked for the grams, that means you need to proceed to the molar mass of sodium azide, which is 65.02 grams. It has to be on top because you're asked for that. And you need to cancel out mole of NaN3. Okay? So that means you cancel out grams N2, mole N2, mole NaNH3, and you get grams NaNH3, which is the one being asked. In which you should arrive at the answer of equal to 38,674.76. 76 grams of NaN3. Okay, please check. I'm having live stream. Nag-live stream ko sa ako because, hi, I have Sir Jonas here, my dear students. I'm showing him that I'm having a live stream discussing our items, test items as a review for our final exam. Because we did not meet last Monday, so I think, because I did not return also the paper, so I think it's good that I have to discuss. I have to discuss it to them. So nag-live stream ko, sir, if you want to watch, so that you can, it can be something that the students, that the students might find it helpful for them, especially if there's so many holidays.
Grade 11.
STEM. Yeah, so this is Sir Jonas. Say hi to him. Hi. Yan na kayo sila comments.
Hi guys.
Hello, study hard for your chem. So any questions about item D? About density. So it matters that you need to do the proper conversion so that you'll get the correct answer. Thank you, sir. Okay. So it matters that you need to be able to convert the units properly so that you can get the correct answer. Sorry for that, Paul. I'm gonna remove my tabs. Wait for a while. These tabs, I think I haven't read them, so yeah, just forgive me for that. Don't get so affected by the tabs. Okay. Any questions about part D? Sorry for the multiple tabs. Okay, any clarifications, any questions about density? So again, most common mistakes aside from the conversion is you just stop until solving for the mass, which is D times V. If you stop until mass, you're not actually giving what is required. The required is sodium azide, but the density you're given is the density of the gas, and there's only one gas here. The only gas here is nitrogen gas. So take note of that. Okay? Now let's go to part E. Part E is we use the mass that you got in part C and you solve for the amount of solid sodium that will be produced. So if you did not get part C correctly, that means you cannot use it. And others use the value in part D, which is wrong because it's part C. So it matters that you analyze the problem carefully. So let me erase this. So it matters that you read the problem thoroughly, and before you use the value from part C, check your part C first. If you really solve it correctly before you use the value right away. So part C's answer was 15.47 grams of sodium azide. Then you have to get mass of sodium. So that means it's a mass to mass calculation. So mass sodium nitride, sodium azide, sorry, will have to begin with molar mass because you're given mass. So you have to always follow it through with molar mass. Sorry, it's not clear. It is 65.02 grams of sodium azide. That's again for every 1 mole of sodium azide. Next, to be followed by mole ratio with what you're looking for, which is sodium, so 2 moles of Na. And then sodium azide is also 2, so that's 2 moles of azide, sodium azide. And next is, because you have to get the mass of solid sodium, that means you need to proceed to having the mass, in which it's just sodium. So it means the mass of sodium is just 1 sodium, which is 22.99 grams. There are others, I don't know where you got your masses. Sodium is Na. It's 22.99 because sodium here doesn't have any subscript. Don't include the 2 for the molar mass, okay? Okay? And so you cancel that out. Grams Na, Na3 is cancelled out. Mole Na, Na3 is cancelled out. Mole Na is cancelled out. And we got grams of Na. Now look at the screen properly. I hope that you are getting this correctly. Okay, I hope there's nothing strange about the values on your screen. So there, putting that in the calculator, you will get the answer of 5.10 grams of sodium. That's it for letter E. Any questions so far? I hope these things are clear. And unsa ni Paul, Madam, will you have problems in which there will be a decoying a given? I don't know how to answer that, Paul. Of course, you won't expect that it's gonna be the same way it's stated in the test or the same way it's stated in the exercises, because you still need to analyze. It's really, the purpose of it is really analysis. And so you need to understand what the problem is looking for. Take note of the situation that is given in the problem, because every situation counts. Okay? It may sound like there will be tricky questions. I won't say it's tricky. It's just that the questions need your focus and your critical thinking and analysis, and of course your problem solving skills. The problem solving doesn't really demand a lot from you. When we say problem solving, it just means that the skill, the roadmap that we're using is the same. Nothing changes with that. But how you approach the problem, like what you're given and what you're required, how you balance, and how you get the molar mass, that's another question. That's also another skill. That's a foundation skill that you need to be equipped at. Okay? I hope that this one is pretty clear to you how you're gonna approach this. Now I'm I am going to encode problem number 3. So decomposition reaction of calcium carbonate. This is the item where most of the students were tricked with their given as to how they will start. Actually, nothing changes here. Starting this will always have the starting values, in which your starting values will always be what is given in the problem. It says that after a 37.12 gram sample of magnesium carbonate was heated in an open container to cause decomposition, the mass of the remaining solid was determined to be 22.15 grams. You understand the situation? It says that you start with 37.12 gram sample. So that's your starting substance, that's your reactant. But there's only one reactant. That means you begin with that. You're 37.12 because that's your magnesium carbonate that you begin with. And after the reaction has been completed, the mass of the remaining solid was 22.15. What is the solid that remains after the reaction between MgO and CO2? You know, carbon dioxide is a gas. That's obvious. That's one thing that I'm saying about hints. So if it talks about solid, that means there's no other way, but it's the MgO. It's 22.15 that's left on the container. That's the solid that remains. So if that's what remains, that means that's your actual yield. That's what you really got. Sorry, this is not supposed to be 22.15. This is supposed to be 17. Sorry, correct. Sorry for that. 17 to be 17.0 grams. 17.0 grams. 17.00 grams. Okay, and then assuming that the reaction went into completion, letter A, you determine the theoretical yield of magnesium oxide and the percent yield, it's just the theoretical yield of magnesium oxide and carbon dioxide. So two things. You're asked for two. Theoretical yield of magnesium oxide and carbon dioxide. And letter B, you're asked to determine the percent yield of magnesium oxide. You might be wondering why I canceled out percent yield of carbon dioxide, because you are not given the actual yield of carbon dioxide. That's why it's not possible here. Oh, that's all. So until letter B. So you may want to take note of the problem if you want to solve it once again when you review for tomorrow. Okay, so as what I have said, your 37.12 grams of magnesium carbonate supposed to be, that's where you begin, because that's what you initially started with. And it says that after the decomposition, there's 17 grams of the solid that remains. So that's the actual solid that remains after the reaction. So that means that's your actual yield. So you can only use that 17 grams once you are solving for percent yield. So letter A, let's start first for the theoretical yield. Some common mistakes there. Some common mistakes is they subtracted 37.12 with 17. You cannot subtract that because 17 is the actual yield. There are other factors that might have changed. There might be other side products that might have formed in the imperfect chemical reaction. That's why we cannot solve for the, we cannot subtract and just assume that the difference is zero. No, you can't. That's why I'm just asking you to solve for the percent yield of the magnesium oxide. So let's begin. Let's calculate for the two things. For letter A, you're asked for two things. Theoretical yield of magnesium oxide and carbon dioxide. So you start with 37.12 grams of magnesium carbonate. What is magnesium carbonate? That's your MgCO3. You may be wondering why Madam Narca did not balance this, because the equation is already balanced. No need to put anything because Mg has 1 O, CO2 has 2 O's, 2 plus 1 is 3. So that's 3 oxygen, 1 carbon, and 1 magnesium. So that means your equation is okay. So you have 37.12 magnesium carbonate, and because you're asked for the grams of magnesium oxide and carbon dioxide, so it's a mass-to-mass calculation. If it's a mass-to-mass, what is next after grams magnesium carbonate? Of course, the next one is molar mass. So that is 84.315 grams of magnesium carbonate for every 1 mole of magnesium carbonate. After molar mass of the given, of course, mole ratio, because we want to calculate MgO first, so that's just 1:1. So that's 1 mole MgO for every 1 mole of MgCO3. And the next is, of course, molar mass of MgO, because we need to get its mass, because the actual yield is in grams. So that's 1 mole of MgO, and the mass of MgO is 40.305 grams of MgO. Let's just follow it through with getting carbon dioxide. So it's the same thing. We begin with 37.12 grams MgCO3. This is to be sure, okay? But actually, here, the moment you get MgO, whatever is the answer here, you may subtract it from 37.12 and you will get the mass of your CO2. That is if you're sure of how much you got here. So the surest way, the most accurate way is you do the long way. Okay, so you have 37.12 grams MgCO3, and of course it's the same thing. You need the molar mass of your MgCO3. And then you have, of course, that's 1 mole. And then the mole ratio. Mole ratio, because it's CO2 now, it's still 1:1 though. So 1 mole of CO2, and then 1 mole of MgCO3. That's to cancel out the units. Even if it's 1:1, you need to put it there because you need to cancel out the right units. Then molar mass of your CO2, which is 44.0 grams of CO2 for every 1 mole of CO2. Okay, and now we're ready to cancel out units. So grams MgCO3, mole MgCO3, mole MgO, so that gets canceled out. And for same thing with carbon dioxide, cancel these things, cancel that, you get what you're looking for. So inputting this in the calculator, you will get for MgO, you will get 17.74 grams. And then for CO2, that's 19.38 grams. In which, if you add these two, you will get your 37.12. That's how you will check whether you get the correct answer or not. Okay? Because both are your products. So the sum has to be equal to 37.12. So letter B, if you are now asked to solve for the percent yield of MgO, so it's AY. What's percent yield again? Percent yield is AY over TY. What's your AY? AY, it's given always in the problem. That's your 17 grams of solid that remains after the reaction. And so, what's your theoretical yield? That's your MgO here, not the CO2, okay? Because you're solving for MgO, so you use 17.74. As expected, it's higher than your AY, 10 times 100. So your percent yield is around 95.38% magnesium oxide. That's a pretty high percent yield. That's pretty high. Okay, are you still there? Are you still there? Do I have some audience? Do I still have some audience? Do I still have some audience? Are you still with me? Okay. Hello. Okay. Please don't hesitate to ask questions. Please ask questions. Okay. I hope I'm giving you some ideas already on how to be able to analyze problems correctly. So I hope this is one tricky problem actually. This is one tricky problem because decomposition reaction, you always start with one reactant, so you can never have LRER sort of problem here. So whatever is your initial substance, if it's decomposition, that means that's where you begin. That's where you always begin. And whatever is left, whatever is the mass that's measured after the reaction, it's automatically considered as your actual yield. And the one that you calculate from your initial given is your theoretical yield. And that should relate to one another. Okay, I think we're ready for problem number 4. We still have 2 more problems to go. I hope you're still sustaining this. So this is how it feels like to be streaming live. So yeah, if there will be more suspension of classes, we might be doing this. This is pretty much convenient for us. But I hope you're learning from this. Okay, let me type in problem number 4 for the sake of those who want to take note of the questions. I'm sure you cannot wait for tomorrow to get to your paper because it's gonna be too late. Okay. Okay, so the metabolic oxidation of glucose, which is C6H12O6 in our bodies, produces carbon dioxide, which is expelled from our lungs as a gas. The chemical equation is C6H12O6 plus your O2, and then you have your carbon dioxide plus your H2O. That's your chemical equation. Obviously, it's not balanced. The others forgot to balance it. The question is calculate for the volume of dry carbon dioxide produced at body temperature, which is, you know, your body temperature, which is 37 degrees Celsius and 0.97 atmosphere when 24.5 grams of glucose is consumed in this reaction. So it's very obvious that this problem is a gas stoichiometry problem. So there are 2 types of gas stoichiometry. I hope you still recall. Gas stoichiometry can begin with stoich or ideal gas law first, or it can be the other way around. So let us analyze this problem carefully. Let me put it correctly. Okay, so it says here that you have to calculate for the volume of dry carbon dioxide, volume, in which if your dry carbon dioxide is produced at 37 degrees Celsius and 0.97 atmosphere. So 37 and 0.97 are values for CO2. So you have T and P. and you have to get V. Are you following? The variables are pretty much clear. Wait. Say hi to Ahimsa torchbearer. Gianna, it's okay. The 95.38. If you got that right, maybe it's with my calculators the way I copied it. So that's okay. That's okay if you have 95.38. As long as the process is correct. Okay. Thank you for that. If it's 95.38. Okay. Shout out, please, Madam. Ahimsa Torchbearer. Hi, Ahimsa Torchbearer. Thank you for participating in our live streaming. Because we did not meet last Monday, I could have discussed this with my students, but we will just make use of internet to be able to reach out to our students so that they won't find it hard to answer tomorrow's test. Is this really a Ahimsa torchbearer, or somebody made an account for him? Who is Ahimsa really? Or are you just making up the name? Anyway, let's proceed to the business that we're having now. So, going back to the problem, are you still with me? Focus. Put your attention in the problem. So, your body temperature, 37 degrees Celsius, and your 0.97 pressure atmosphere are the values for CO2. Take note, it's about the CO2 because our dry carbon dioxide is produced first in the metabolism inside our body. And then you're asked for the volume of CO2. So the variables T, P, and V are all clear. That means it's about the ideal gas law. This is not at STP. This is the common mistake in the test because others assume that it is at STP. If it's not mentioned that it is at STP, that means you do not use 22.4 liters. Okay, don't use that unless it is at STP, but it is not mentioned here. That means it's only ideal gas law. Megan, to answer your problem, focus on the conversion for ATM, PA, and HG only. That's it. So just for atmosphere, Pascal and millimeters mercury. And for volume, same thing, same with, you may focus on M cube and liters, because you need to have it in liters and then milliliters. Okay, no temperature conversions. Thank you for that question. No temperature conversions tomorrow. Yeah. Okay, did I answer your questions? No temperature conversions, but you need except Kelvin. Except Kelvin. Which is if you need to convert that is plus 273 only. So going back to the problem, do you have any more questions? Do you have? Okay, I hope you're following this through. Okay, so because this is about CO2, but if you know you have P, T, and you're asked for the V, you still cannot solve for V because you lack one variable. If you look at the ideal gas law equation, it's PV is equal to nRT. And for you to solve V, of course, that's nRT over P. And obviously you're given P and T, and you know R, which has to be memorized. Your N, you're not given N. What is N again? N is for the number of moles. It's the number of moles. But where will we get that? It should be moles of CO2 because this is volume of CO2, not volume of glucose. It's volume of your CO2. So let me clarify that. Okay, so that's volume of CO2. That means I have to get N of CO2. Where will I get that? You get that from here. You have 24.5 grams of glucose, but it's not CO2. Oh, so that means you have an idea that you have to begin with stoichiometry. You cannot proceed to this unless you pass by the stoichiometry of converting mass glucose to moles of CO2. You just need the moles. So how do you do that? Let me put this on the side. So you have 24.5 grams of C6H12O6. And of course, you start with the molar mass because you're given the mass, so you automatically start with your molar mass. That's 180.18 grams of glucose. So C6H12O6 for every 1 mole of C6H12O6. To be followed by the mole ratio of glucose and CO2. So it is 1 mole C6H12O6, and then that is 6 moles of CO2. I forgot to place the balanced chemical equation. The balanced chemical equation of this, it's 1, and then 9, 6, and 6. And again, just to segue a bit, if you're balancing combustion reaction, remember that you start with carbon. If there's 6 here, so you may put 6, and then the moment you balance carbon, follow it by hydrogen. So if there's 12 here, so you put 6 to make it 12. Then the last is oxygen. So you have to total your oxygen here for H2O and the oxygen for CO2. You should get a total of an even number so that you can put a number here, O2. And because there's a 6 here, you should just get an even number total on the other side. So that's why you have to get used to balancing combustion reaction. That's the hardest type of chemical equation to balance actually. So I hope that you can get that right tomorrow. So that's 6:1. So canceling our units, so that's grams C6H12O6, mole C6H12O6, and then so we get mole CO2, and putting that in the calculator, please solve with me. Up to 2 decimal places, you get 0.82 mole of CO2. So that's 0.82 mole of CO2. Now we're ready to solve for the volume of your carbon dioxide. So volume CO2, again, the formula is there. It's nRT, so that's N is 0.82 moles. That's what we get from your stoichiometry. R, for those who forgot, it's 0.0821 liter atmosphere per mole Kelvin. And then times temperature. Temperature is 37 degrees Celsius plus 273. That means 310 Kelvin. Over P, no need to convert. That's just atmosphere. So 0.97 atmosphere. Okay. And then we cancel out units if they're okay. Mole cancel out. Kelvin gets cancelled out. Atmosphere gets cancelled out. And we're correct. We get the liters, which is the correct unit for volume. Inputting that in the calculator, we will now get 21.52 liters CO2. Okay, let me know if you got that right, please. Yes. Yes, ahimsa. Ikaw ha, you are using alias. Okay, so any questions so far? So this is gas stoichiometry. There are only two ways. There are only two ways for gas stoichiometry. Either you begin with stoich first, which is in this problem, then ideal gas law follows. Or you can begin with this and then followed by the stoichiometry. It depends on the type of problem that you're given. So it matters that you analyze the problem carefully tomorrow as to what substances are these variables for and what I am given and required to solve. I told you always that you cannot mix up substances. You need to isolate each of the substances before you make use of their values. When we use this, we use glucose. Using stoichiometry, the value of glucose, we use stoichiometry so that we can shift to CO2, so that this value of CO2 can be used to the formula of the ideal gas law equation to solve for its volume, CO2's volume, not glucose. Okay? Okay, hang on there because is 0.84 acceptable answer? Yes, Irina. Yes. Yes. No problem. Okay? I'm just using my a different periodic table in solving for my math. I didn't use the one in the book. Sorry for that. That's why there's a little difference of the mass. But that's okay. As long as the calculations are the same and more or less the values are the same, there's no problem. I'm not so exact. I'm not so strict with the exactness of the values. Okay? Okay. Any more questions, guys? Any more questions? Okay, now let me erase this and let me proceed. At last, we are about to end the items of test 2.5. We're about to end this. Okay, let me encode now the ranking of the given substances. Now, this one is a bit challenging because it has conversion, a bit of conversion, but it's the easiest because it is all STP. So it says rank the following substances in increasing number of moles. Number of moles, so that means you have to get N. Then assume that all of them are at standard temperature and pressure. What are these substances? Letter A, you're given 4.50. I'm just using one item, okay? But more or less, it's the same technique. Ammonia gas. Letter B is 45.0 cubic centimeter of carbon dioxide gas. Dioxide gas. And letter C, you have 5.05 cubic meter of oxygen gas. Take note, what is ammonia's chemical formula? It's NH3. And what is carbon dioxide? Of course, it's CO2. And what is oxygen gas? It's diatomic. So what is diatomic? It has to have a 2 subscript. What are again the 7 diatomic molecules? If it comes out, you have your 7. Your neighbors, nitrogen gas. Let me put that here for the sake of those who cannot follow if I just speak it out. So here's 7 diatomic molecules are the following: your nitrogen gas, your oxygen gas, your fluorine gas, your chlorine gas, Cl2, your bromine gas, and then your iodine, and lastly your hydrogen gas. So that's 7 all in all. So if I give you these gases, automatically they should have a 2. So what does it mean? That means if you plan to solve for its molar mass, they have to be multiplied by 2. That's it. That's what you need to remember. And when you balance them, of course, it has to be taken into consideration. So how do we arrange the three gases here? How do we rank them? Letter A, there's no problem. If we have STP, what is it that we remember if it's STP? STP's conversion is always you can use what we call the molar volume. What is molar volume? That's the conversion that will speed up your conversion factor. Instead of using the PV is equal to nRT, you can use the molar volume right away. It means that 1 mole of any ideal gas occupies a volume of 22.4 liters. And we assume that all these gases are also ideal, so we can use this conversion factor. So for letter A, because you're given 4.50 liters, you can just use right away your 22.4 liters is to 1 mole conversion. That's it. So that is 4.50 divided by 22.4. Then you will get the answer to be 0.20 mole. This is your ammonia gas. That's all. That's all. That's just it. And letter B is you're given cubic centimeter. What is the conversion? You know that 1 cubic centimeter is ml. And 1000 ml is 1 liter. So that means 45 cubic centimeter should be divided by 1000 to get a liter. So that becomes 0.045 liter. Okay? We use this conversion to convert our 45 cubic centimeter. It has to be divided by 1000 because of this conversion factor. It has to be liter. Before you can use right away your is to 22.4 liters, your molar volume. So we can cancel that out. Liters cancel out. I get a mole. So that means I get right away the answer of 2.01 times 10 to the negative 3. And this is CO2. Okay? Or 0.002. You may have that as your answer. Letter C, it's an M cube. Same thing with the previous problem, 1 M cube. It has 1000 liters, so that means my 5.05 has to be multiplied by 1000, so that becomes 50 liters times 1 mole is to 22.4 liters. You just need to convert it properly. So liter gets cancelled out, and I get an answer of, my answer is 225.45 of O2. Okay? So now you can rank. Now do not be misled by something like this. It's not 2.01, but it has a 10 to the negative 3. That means this value is 0. To the left, so 0.0201. That's a very small value. So when you rank this in increasing number of moles, you begin with the one with the least is CO2, of course, then followed by your NH3, and so the highest is O2. So that is in increasing number of moles. Now, some things that might trick you, some possible questions in this kind of items is that you might not be asked for mole. What if you'll be asked for volume? That means you reverse your 22.4 and the 1 mole. The 1 mole will be below, 2.4 will be on top. That is if you're given the moles, right? That can be another modification of the problem. That is how you do modifications in this type of ranking problems. So as long as you have to remember what conversion you're going to use. If you're given 22.4 this variable and you're looking for this, and take note that if it's again at STP, you can just use this one right away. You don't have to use the ideal gas law equation because it takes time. You might not be able to solve the problem fast enough. Okay? About this last item, any questions? I hope that this clarifies some of the questions you've been asking yourself about the test 2.5. Tomorrow you're gonna have your test papers before the start of the test, and I hope that you can see your mistakes there, and comparing this with what I discussed here, you already know how to approach them come examination time. So your exam tomorrow in chemistry will last for 2 hours. 2 hours, and that's going to be a lot of problems to solve. Mostly problems are connected to one another. There's not much of the problems, but each problem will have multiple questions. So you need to be careful with how you are solving these problems so that you can really get the accurate answers. Huh? So, any questions? Any questions so far, guys? So I think I need to stop already this. I hope that the others who were not able to do live streaming can have time to go over the answers to the items. Let me wait. Let me just end this. This is my problem. I don't know. Just eat my lunch, but I don't know how to end this. And I hope that you are. This is my it's just an amateur live streaming. It's my first time to do this. I hope that we can do this more. Okay, wait. Yeah, thank you so much for watching, and study for your other subjects. Study and don't be tempted to watch something else, okay? Let me. Yeah, you're welcome. You're welcome. I will end this now. I'm still gonna figure this out how to end this. Thank you. Thank you. No, not uploaded. So stop broadcast.